Friends, welcome to our channel. Let's have a look at a newly appeared problem, longest balanced substring 2. So the 2 actually has a larger problem size, therefore we are going to directly look at this 2, right? So here we are given a string S consisting only of characters A, B, C. So here it introduced a definition that is called balanced substring. A substring is balanced if all distinct characters in the substring appear the same number of times. So we want to find the length of the longest balanced substring of S. So here we have 3 examples. So the third example is very easy. So you can only, the longest one is either AB or BA because they appear both once, right? But you cannot have 3 because here the whole string A appears twice and B appears once. So in the second example, so you can only have ABC, right? So because each character appears once, but you cannot see this one because C appears twice. You can also not do this 4, right? So certainly not the whole string. So for the first one, you can have A, B, B, A because both A and B appear twice respectively, right? So here, as I mentioned at the very beginning, the length is bounded above by 10 to the power 5. This 10 to the power 5 is a large number. Therefore, we need to think of term complexity when we do the coding. The second one is a consistency assumption, which says that the string contains only the 3 characters A, B, C, right? So for this problem, this I would say it marked medium, but for some people, it indeed medium or even easy. But for some people who do not practice a lot in leetcode, this might be a hard problem, right? So here, let me first tell you that. So this problem actually has a prototype problem, that is problem 325. So the maximum size subarray sum equals to k. So in this problem, we want to find a longest subarray with sum equal to a given target, right? So there we are using partial sum and dictionary and check method. So this problem here actually can be regarded as a multi-dimensional version of problem 325. So this is the first point. The second point is that in problem 560, so it counts subarray sum to a given target, but this problem is counting slightly harder than problem 325. So for this problem, again, you can also do count the number of balanced substrings, right? So similar, actually. So the strategy will be the same as in problem 325. So we're going to use dictionary and check idea with the help of partial sum or prefix sum. So here, I guess, the analysis of the problem is crucial. For the coding, it's almost identical to problem 325 in essence. So first, I'm going to have a list. So the list is a list of tuples, length 3. Count the number of occurrences of A, B, C, respectively, before a index. So here, so actually this up to include this index, right? So it's the occurrences of A's and B's and C's up to index I. So then we are going to consider 3 cases. So one case is that the substring is balanced with 3 distinct characters. The second case is the substring is balanced with 2 characters. And the last case is 1 character balanced. So let's analyze the first one. So here again, we use some strategy called decoupling, right? So here, let me write. So decoupling is actually a very widely used idea, like in, for example, system design, right? Or in mathematics, right? So here is an example. So for this substring is balanced with all 3 characters A, B, C. So it means that in this range, the number of A's equals, this is the number of A's, right? equals the number of B's equals the number of C's, right? So now I want to do some transformations, basic mathematical operations. If you see the first equality, so we can separate the J's and I's, so which is equivalent to say AJ minus BJ equals AI minus BI, right? AJ minus BJ equals AI minus BI. So if I look at this one and this one, so of course you can also look at BC, but it's the same thing. So then AJ minus CJ here equals AI minus CI. So this 3 is equal to this one, this 2, right? So in other words, for this substring is balanced with the 3 characters A, B, C. If and only if and PI and PG have the same quantities A minus B and A minus C, right? So here actually the sign is not important. You can consider B minus A or A minus C, C minus A, right? So this is the first case. The second case is 2-character balanced. So if the this substring is balanced with, let's say, A and B, right? Then the number of A's should be equal to the number of B's, and the C's should be constant, right? So in other words, C does not appear, right? So in this case, so if we do decoupling again, so we get the difference of AJ with respect to BJ equals that of AI with respect to BI. So this realizes the separation of G and I. This is the so-called decoupling in this context. And CI equals CG, right? So in other words, PI and PG have this quantity, A minus B, and C is fixed. So we also need to consider permutation. For example, it's balanced with A and C. So you're going to consider this quantity, right, with B. And balanced with B and C, you need to consider this difference and A. So as to which minus which, it does not matter. You can consider A minus C or you can consider C minus A, right? So if it's case 3 is 1-character balanced. So if 1-character balanced, for example, A, it means I don't care about the occurrences of A, but I just need to make sure the number of A, B's and number of C's in this range does not appear. So in other words, so we consider same and B, C, right? Or if we consider permutation, right, balanced with B, you have same AC, and balanced with B, you have if balanced with B, you have BC, balanced with say A, you have BC, and B you have AC, right? C you have AB, right? So this is the idea. So once you realize this idea, then writing the code should be rather straightforward. Here, let me write the code. So here, actually, I would suggest that you can first try this problem, and then you do this, right? So maybe as a follow-up video, we can do a video for this problem again. But now let me first finish this one. So first I get the length of this string. So let's call it S. So I can make it capital S. So this is the one, and then let's get the list. So here I need to use a dummy one because at the very beginning we need to consider 0, 0, 0, right? So let's say 0. This is the index shift. It does not matter. Then I want to get the cumulative ones, right? Cumulative A's and cumulative B's and cumulative C's. You can do it separately, or you can write it in some compact fashion. Let's see, for C in S. So let's first append this one. Append P negative 1, the last one. But we cannot just directly append this one because this is the list. It's mutable. So here I'm going to make append a copy of this one, and then increment the corresponding places, right? So for example, P negative 1. So then we get the either the index, let's say A, B, C, right? So we get the index of the current character. If it's A, it's going to be corresponding to index 0, B corresponding to index 1, and C corresponding to index 2. So this one I'm going to increment by 1, right? So this way you can print out this guy, right? So you will see at the very beginning, so nothing appears. So if you look at index 0, A appears once, right? If you look at it up to index 1, so B, right? And then B appears again, and then A appears, and then C appears, right? So this is the status. So now what we do, so let's initialize an answer variable. So we are going to return its final state. And then I'm going to use a dictionary. So this dictionary is checking the index for first occurrences of this key corresponding to the 3 cases. So I'm going to use a first occurrence, or use just this dictionary, or you want to specify, right? Then I'm going to iterate. So for I and A, B, C, right? In enumerate P, right? So then we consider different keys. So for K in, so let's see, A, B, C, right? So this, we should have same A minus B and B, A minus C. Let's see, this is the one K. And balanced with 2 variables. So we want to have C is fixed, right? So A minus B and C. So if balanced by BC, right? So we want B minus C and A. If balanced by AC, right, or CA, so we get C minus A and B. So if it's one character, so A, so we should have same BC. If it's B, so we should have same A and C. If it's C, so we should have same A and B, right? So for those cases, let's see. I should have yeah, so I think it's the right indentation, right? So here what I want to do is answer is going to be the max of the pre-state, and then the current index minus answer get the key, get the first occurrence, so not the answer, the first, so get the key. So if we cannot get that key, so we're going to have this default value, that is I. So then I minus I will be 0, right? So this is the case. Now actually we are going to update this one. So we use set default. So key and corresponding to the current index. So this function is very useful. If the key is already appeared in the dictionary, so this place has no effect. If the key does not appear in the dictionary, so we are going to set its value to be I. In other words, this will be the first time this key appears. The reason we just check the first occurrence of a certain key is because we want to find the maximum length, right? So now after those, you can do the return the answer. So that's actually the full code. Now let me first run it. Unmatched, say, max I minus this one. This should be 2, right? Yeah, it passes the 3 cases, 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess that's basically about it for the current problem. So I would encourage you to work out these 2 problems, problem 325 and the problem 560. You know, it's actually the same method, but as I mentioned, this problem here is a multi-dimension version of problem 325. And if we want to see what's the new ingredient, that may be the decoupling. For if you can analyze using decoupling, should be rather straightforward to do the problem. So with that said, that's it for the current video. In the follow-up video, we're going to do problem 325 as a practice. Thank you for watching.